Alright, welcome back, and let's now talk about sorting. So now in our demo, we have found numbers in an array. Now we want to sort the numbers that are in the array. So I'm going to call we'll use the same function, or the same array numbers, and I'm going to create a new class, and I'm going to call this sort. Okay, so in here we'll do the classic bubble sort. So public static, for now we'll just have it be void. Call it bubble sort. Okay, so bubble sort, all we need to sort something is just the array. So I'm going to say integer, we're going to call this data set. Okay, now I'm going to call this function. So call the bubble sort function. Again, all it's going to be is sort dot bubble sort past the data set. Okay, alright, so here we go. And let's see, why is this flagging an error? Oh, it's not data set, it's passing numbers. There we go. Okay, so the bubble sort is going to look like this. So we are going to basically compare each value to the adjacent value and then basically swap them. So it's going to swap as it goes along, and we'll kind of loop through this a couple of times. Okay, so let's do this. We will do, I'm going to have a do while. Actually, before I get to do while, what we're going to do is to do a for loop. We'll do integer I equals 0, I less than data set dot length, and then I plus plus. So what are we doing? We're going to iterate through the entire array, right? And so it's very simple. The idea, if we'll say if the data set at I is greater than the data set value, right, at I plus 1, then we're going to do some work. Now, first of all, if we're going to compare the value of 1 to the one greater, then we don't need to go all the way to the length. We need to go to the length minus 1. Okay, so if the value at, say, 0 is greater than the value at 1, then we're going to move that over to the other one. So this is a little bit of a just a two-step process. We need to have a temporary variable, so I'll say temp equals data set at I. Okay, then we're going to swap. So we're going to say then our data set at I is going to equal data set at I plus 1. And now our data set at I plus 1 is equal to temp. Okay, so let's take a look at this. So every time this occurs, I'm going to print. Can't print an array too easily. Let's see. I'm going to come down here and just have a public static void print array. In fact, I'll have this be private just to kind of make it even more official, right? So integer array. I'm going to do for each loop for integer I in array. We're going to print system.out.print print I. Okay, so every time it switches, I'm going to call the print array data set, so we can see how the print changes things. In fact, let's say sysout swap. Okay, so again, we're just going to go through, and then when we find a swap, or find a case where basically something on the left side is greater than something on the right side, we're going to switch those two. So, and then every time that happens, we're going to see the progress here. Okay, let's see. It's not what we wanted here. Okay, we don't want to print that every time. That's right. We want to print it just once. There we go. Alright, now we can run it here. Okay, so our initial array was 10, 25, 4, 33, 26, 73, 132, 5. Okay, so the first time we swapped, we had 10, 25, that's good. 26 should switch with 433, but that got lost somewhere. Okay, so let's come back to sort, see what we might have done wrong. Okay, we don't want it at 1, we want it at I. Now we can run this again. Okay, 10, 25, 26, 43, 73, 132, 5. So the first swap should occur with 4, 33, and 26. In fact, let me do this here. I'm going to make this public. Or I'll make it private. Okay, so right as soon as we get in, I'm going to call the print array and pass data set. So in other words, now we can see the sysout original array. Okay, and actually this is going to be on a line. No, that's not going to be on a line. Now that will that be? Then when we're all done, then we're going to print out a line. There we go. Okay. /n. Okay, now this should all appear pretty nicely. There we go. So original array. We swap. See, even then, what are we missing here? /n. There we go. All right, so that's how things look the way they should. Okay, here's the original array. See, even there, we don't want to say swap here. We want to put it right there. All right, it's just kind of making these a little bit nicer for us to debug, see the process. Okay, there's the original array: 10, 25, 4, 33, 26, 73, 132, 5. We swapped 4, 33, and 26, and then we swapped. What's the next one we would have done? Is 433 and 72, and then 132 and 433, and then 5 and 433. Okay, so this is all good. What do we see happen? It pushed the large value all the way to the right. Okay, so that's good, but that just pushed one value. So it basically it sorts by pushing the large values to the right. It doesn't push values to the left, it pushes large values to the right. So what we want to do now is iterate through this again, right? Because what about 132 and 5? So what we need to do is come back and enhance our sort. And what we can do, some people will actually do a for loop within a for loop, but that's not necessarily the most efficient. What's probably the most efficient is if we have we'll say in fact, I'm going to just take this off here. If we have a Boolean, we'll call it swapped. We'll initialize it to false. Okay, so in other words, if there's a swap, then we know that we need to iterate through the loop again, right? And so as long as we do, basically as long as there's a swap, then we're going to loop through. So I'm going to have a while condition while swapped is true. Okay, so again, the intuition here is if there's a swap, that means there might be something else that we need to iterate through. If there's no swap, then it means the iteration it's sorted, right? If there's no swap, that means that we didn't, or it means that there's nothing left to sort, and that means that we don't need to iterate through again. So there might be a case where we can sort it before having to loop through the data set twice, or not twice actually, n times, right? So this might be able to save us a couple iterations. Okay, so now let's run this again, and there we are. So there's our finalized array there. Okay, so very good, and that's it. This is how it started out, and you can kind of see things move each comparison here as it moved. And I should say at the end of one of these swaps, I should say sysout, I should say something like iteration, right? Okay, that's not what we wanted. I don't know why that happened. Because that's just printing. I'm not sure why the iteration printed so many times, because all we want to do is print every time after each. Right, so basically each for loop pushes one value to the right. So this for loop executed, it pushed 433 all the way to the right. The next loop pushed, it would have pushed 132, right? So pushed 132 to the right, and then it pushed 73 to the right, and then 26 and so forth. So had to push 5 all the way to the left, but it did that only because it actually pushed the other values to the right, is the way to think about it. If we would put a value like 20, say 35, how would that change things here? Alright, so it's got to iterate through it quite a more number of times, so it's got to make up for that entire other variable that's set out there. Okay, so anyway, that's the algorithm here. This is the magic, right? So when you swap, basically what you want to do is you have this temporary variable that you're passing into a value from the array, and you're in order to swap it, you need to have a third variable so you don't lose that value, and then you're iterating through it as long as there's a swap. So that's the it's not too complicated. People get tripped up on this swap method right here, and then they also get tripped up on how long to loop through the array. The fact you have to iterate through the entire array once makes sense. How do you need to iterate through it a second time? Well, we actually took care of that because we knew we used our common sense, our logic to say if there was no swap, then actually this should be inside the do. And let's see. That was actually a significant change. We need to have, now why we have, this is declared within here. Well, I guess we can just say this, and each time we go inside this loop, we're going to redefine it. So the whole point of having this this swapped variable here is to save us from having to iterate through this too many times. So every time we enter the loop, we're assuming that there's no change, and only if there's a change do we change this value swapped. Then if there is that change, then we need to realize that there could be other changes left. So if there are no changes, then we know that the array has been sorted. So there you go. Sorry about the little bit of messiness there, but the swap should be initialized to false every time that do while the do loop starts over, and then only if there's a match are you reassigning that value to true.